data flow documentation or process modeling is. So we're really about, when we're in system analysis and design, looking at business or operational processes, and we need some way to capture the steps in those processes. We're really interested in the information aspects here. What information is used, what information is produced. And we're going to produce what are called logical diagrams. Not logical in the sense that A follows B follows C, kind of in a logical in the sense that they represent what needs to happen without getting into a lot of detail about physically where it happens or who does it. And we'll come back to that. But if you kind of can go that, and we'll be focusing on a technique, it's called data flow diagrams. There's a lot of different processing diagrams. There's event, process, EPC, event, process, I forget what the C is, EPC diagrams, BPMN is business process modeling notation, and they all are about the same thing, representing in a diagram what's going on. So you got to be able to read them, and we'll do some things about where you create it. The examples say worth 1,000 words. So why do we do it? Clarify requirements. I've got a student doing this. This happens here, and it does put it in a diagram. Maybe that's slightly eye candy, but nothing wrong with that. Sometimes the diagram can take lots of words and put it in. And you can use them to say, oh, here's how you're doing it, and here's how we propose that you're doing it. And it doesn't count on the computerized system, right? Paying cash for a milkshake can have a process model. The lemonade stand with a little kid, and they don't have card readers or any information. So you realize there's kind of 3 reasons that we do this. The 4th one I'd understand, and maybe it's related to this, is if you can't put it in a process model, you don't understand it. And if you don't understand it, you need to go back and figure it out. So it's a good way to say, do I get it? And so kind of talked about that, what data flow diagramming, it's the technique. This logical process describes, without the details of exactly how, it just needs to happen. Somebody provides cash, we provide a receipt. We don't say, oh, take a ticket out of the pad or enter it into a computer. That's what a logical process is. And that's what we're interested in mostly here. The physical processes really depend on the client and how they do things. But we're interested at this level, okay, what goes on. Then there is a data flow diagram. And once you get used to it, and even before without much training and background, as long as you realize that the rounded rectangles, sometimes circles, represent processes, okay? Processes, they get numbers to identify them. That just helps us differentiate. Doesn't mean that 2.2 follows 2.1 necessarily, but that could be the thing. Processes always get names in addition. Processes are always activities. Determine, confirm, prepare, update. Okay, kind of like that's what we're doing in use cases, not use cases, but activities. Entity and activities. Activities begin. Might be talked about the other class. We had something where it's an action. Okay, so if you're putting it in a process, action, right? Great. Actions consume some inputs. So this is I'm now looking. I know nothing about this process, but I know there's a sub-process here called determine chemical approval status. Somebody gives me a chemical needed. Okay, I need sodium nitrate, right? So somebody communicates that to me. Who does? Oh, it's the lawn chemical applicator. Says, I would like to use sodium nitrate on the thing. I've got a process here that determines whether that's going to be approved. How do I approve it? I pull a chemical approval status from the lawn chemical supplies data store. So this is a data store because it's got this label. Don't need to worry about the numbers being in order. It just distinguishes. We have a data store D1. That's a lawn chemical supply. And I can infer from this, somehow we're going to store approved chemicals, not approved chemicals, right? So somehow I pull this. I'm not interested yet in the how, but I'm interested in the what. Okay, so I get a approval status, and perhaps if that chemical that they've asked for is not approved, I say, nope, you can't. It doesn't say what to do if yes, you can. Oh, here it is. Yes, you can. Then the approved chemical goes down here. right? Now, these aren't really testing the chemicals. These are processing signals, okay? Data that says, yes, you got permission to use this. No, you don't have permission. I got all that from looking at the diagram. You should be able to get that too, okay? And so I get a lot of richness about what's going on. Then, oh, there's the request quantity. So I've asked for sodium nitrate. I need 15 tons, okay? And, oh, from this lawmaker supply, we have a available, okay? And, there's some of this thing that comes out that says valid chemical quantity. So that might be something, if we dive into this process, if they want 2 tons and we only have a ton, then what they get is a ton, right? But some way, there's a way to determine what a valid quantity of this is, right? And then, we wait to confirm the request. Are you sure? So we've got that as part of the process. So you can read these as well as I can. And so there's a confirmation. First we say, oh, are you sure? And then we get a confirmation, and we get the quantity goes in here, which is an update. We get the confirmed request that prepares, oh, yeah, come on, over and pick it up. It explains how this process is going to flow. So we've talked about processes. I've used a lot of pointing to the data flows, okay? Those are what on ARCs. Those are things. Don't ever tell me that, oh, the long chemical forwards chemical needed to. No, the fact that they forwarded it is here. This better be a noun on all the ARCs. Better be a verb that starts all the processes. The things in squares, or these rectangles, squared rectangles, are called external entities, right? They are outside what we're documenting, but they're usually the providers, the vendors, the customers, the things outside systems that we interact with. And so, an LCA is just somebody, maybe a business that wants to apply lawn chemicals. So we don't document why they need the chemical. We just know that they're the trigger for us figuring it out. You can think of those as sources and sinks. What do we do when we get the chemical outage? Oh, we tell purchasing, right? Pickup notice goes down to the chemical supply warehouse, right? And an authorization goes back here. So these are external. We don't know what the chemical supply warehouse does with it. We just know that it's our job in the process to provide that. And these rectangular things are data stores, information, right? So somehow the new chemical request gets in the list of chemical requests. Doesn't mean it's a database, but that's where we're headed. That's Data Flow Diagram 101, and I can tell a lot about this business because somebody took the care to do the data flow diagram, and it replaces a whole lot of words. And now I'm ready to ask questions. What happens? How do you determine the request quantity? So I think the rest of the chapter is just telling you in some more words what I just said. So great. Process, data flow, data store, external entity, and those are the only 4 that happen, right? External to the system, but it interacts. We don't document what an external entity does. Great. Some rules of the game, and that video that I pointed to you last week has some. There are some rules of the game. Every process has a number. A name has got to be a verb phrase, a description. Got to have 1 or more output data flows, right? Got to produce something. Usually 1 or more input data flows. I guess you could have a white hole that produces something, but that's usually it's kind of unusual. All right. And you can get computer-aided software engineering. Visio is a lightweight version, and sometimes they're rounded rectangles, sometimes they're ovals. We can deal with that. Data flow is a name, a noun, a description. I mean, this is just, I've already told you all this, right? And I can label the arc. I've seen them both ways. Don't worry if in Visio you get something that looks a little bit more like this or has this and doesn't bold or kind of dark blue the top. That's not what we're after. We're after a data flow diagram that explains it, and I will understand if you have a rounded rectangle without a blue top. It'll be good. But read these. Internalize them. When you draw a data flow diagram, make sure that you go back. The only thing that has any action is the process. So if you say validates the data flow or something here, or these are not actions, those are things. All the actions happen in processes. So maybe the hard part of data flow diagrams is collecting what are the actions and what are the updates. You need to study this, print it out if you need it, have it at your elbow. I'm assuming you got it. All right, data flow diagrams have what's called hierarchical partitioning. We can't describe how GRU manages its budget in one diagram. And so there's this notion of decomposition. Start with the whole GRU budgeting process as a context, and then break down the pieces. Departments submit, funds are allocated, regions approved, things like that. So this notion that we take a big process and break it down is fundamental. And oh gosh, I need to get rid of some of this. So here's the idea. Here's a context diagram. Context diagrams, as you should know, have just exactly one process and the key external entities. It's rare for a context diagram to have data stores. That's too operational, right? So all we know is entity A provides an X, gets a Y, and entity B gets a Z out of this thing, okay? Then we break that context diagram into what's called a level 0 data flow diagram. Now what's important is it's called leveling. Entity A, entity B both appear. Entity A consumes a Z. That needs to be at level 1. Entity A provides an X, consumes a Y. Provides an X, consumes a Y. But what the level 1 does is break down into pieces how that happens. So the X goes into this process 1, okay? And process number 1 that they call it process T. And that produces some little data flow called a B. It only exists in here. That's fine. And process U eats it up and stores an N and pulls an M from there. Oh, by the way, it also provides the Y back here. So it's almost like if we draw a circle here, then this needs to conform, right? And the processes inside break that up into a greater level of detail. Then it might be that this process 2 is too complex to really just say, here's how to do it. So the level 1 data flow diagram takes a process from the level 0 diagram, breaks it up into detail. Important thing is, the process numbers all begin 2. Like 2.1, 2.2, 2.3. Means we're breaking up 2, right? If we're breaking up 3, it'd be 3.1, 3.2, 3.3, 3.4, 3.5. Not everything has to have 3. They're doing 3s here, just, okay, to do. Notice the process 2 eats a B, produces a Y, and has this MN interaction. It also produces an A, so produces a Y and an A. So at level 0, it looks like this B is coming from nowhere, but we know where it's coming from. It's coming from process T, and that the context for this is given here. So it's important that these inputs and final outputs are diagrammed, but inside, here's how you do this process. And so you produce a K and an H, and then this process does that. And so you ought to understand how this relates to that. It's almost like I could wire this B there, wire the Y there, and wire the A in there, right? And goes. And then we might decide that, oh, this is still too complicated to break down. And so process 2.2 gets broken into 2.2.1, 2.2.2, 2.2.3, 2.2.4, 2.2.5. And a lot of times your data flow diagram is going to be 60 or 70 pages by the time you've broken it into the subprocess. Or if you put a diagram on each page, 50 or 60 diagrams. All the time at Ernst & Young when we were looking at a fairly simple kind of process, it just, by the time you got there. But the important thing, process 2.2 eats a K and an H, produces a G and a C. So here's an H and a K to be eaten. There's a G coming out. There's a C coming out. Those are important. And what happens internal is you as the analyst, okay, that needs to happen, and then they get it signed off and on like that. Okay, so that's that idea of, I call it hierarchical partitioning, decomposition, further levels of detail. Okay, big thing, context diagram, better have one process. And usually it's not even an action process. It's like information system or GRU budget or something like that. It's the one case where the process might not have a verb. Usually you don't number it. Here I notice they numbered it kind of 0, and then these get numbers 1, 2, 3. It's common format that on your context diagram not to do that. So, and we had a picture one. We talked about the level 0 diagram. Backs up. the context diagram. You always have a level 0 diagram. This idea of balancing is that input-output thing, right? That is, balancing is input, output, output. Input, output, output. That's balancing. And there's always just one of those and always just one of those. There might be as many level 1 DFDs as there are processes here, right? Level 2 DFDs as there are processes on a level 1 diagram, but 1, 1, and as many as you need of these. Okay? So that's just part of the organization. That's balancing. So got it all in there. Talked about decomposition, the new subprocess for children, and it just the children break it up into detail, but it is the same process, right? And keep that balance. The inputs and outputs have to match. It's the biggest thing you're going to get scorched on in grading wise on this is, okay, you didn't have a diagram that balanced. And, oh gosh, look at here. And so just what I just said. Processes, data flows, yeah. So a level 2 just breaks up a level 1 process. Like a level 1 breaks up a level 0, and in a way, the level 0 diagram breaks up the context diagram. And always the balance. That's inputs and outputs match from one diagram to another. Yep. And yeah, if there's conditional and error processing, you tend to just you include both. Oh well, if we had that confirmed chemical and non-confirmed chemical, show them both. It doesn't mean they're all produced all the time. It's what comes up. And similarly, kind of error processing. What if the computer's down? We tend to not worry about that. It's kind of like the happy path in a use case, right? So process descriptions. At the bottom of the data flow diagram, we have to describe what each process does. And there are some ways to do this. We'll probably just either use structured English or English. Okay, the client looks at the resume and files it with this kind of thing. But so we won't be too worried that each of those nuggets, when you get down at the bottom level, each of those subprocesses needs some description that describes how to do it. Okay. Look at there. Start with use cases and requirements definition to go. So they're kind of the third on the set that they all interact. An individual use case might lead to a data flow diagram or a level 0 process on the data flow diagram. Okay. And the project team, this is what you're doing in your assignment coming up. Okay. And you can use case tools that make it easy. Visio's a little bit easier. They got this thing, it's called Visible Analyst. That does it. And we have a product like this that I could put you in touch with. I decided it just gets a little bit complicated, so I've done that. All right. And so this is how you kind of do it. Draw a circle, put your main thing in it, external entities, arrows, context diagram ought to be fairly straightforward. You might come back and say, oh, I need another entity, something like that. But the circle, process or system, and the big flows. Okay. And then so for each use case, what is the use case? What does it need as an input? So draw a circle for the use case. Oh, and here's the inputs I need. Here's the outputs that get produced. Okay. And then hook those things up, the outputs. Well, where's that output consumed? Or does it go back to somebody? In which case it goes to an external entity. That's what they're saying here. And then you break it down based on the steps. Okay. And so your use cases help you illuminate your data flow diagrams. It just really is now hooking up kind of a chain of use cases and how they all come together. All right. I already said it. I said it here. No data stores are included. All right. So there's a context diagram. You can tell a lot about what the heck's going on here, right? So it's holiday travel vehicle sales. Okay, I can think about that. And the salesperson puts in some offer details. The salesperson gets a rejection. The customer gets a pending offer. Customer provides payments. Anyway, you get a lot about who's doing what there just by looking. That's what Yogi Berra said. You can observe a lot just by looking sometimes, right? And so DFD, think of a process with just the inputs and outputs that are kind of going nowhere. That's what a DFD fragment is. And then you hook them up to the relevant consumer or provider, right? So you have a use case, and it's talking about the summary of inputs and the outputs that get produced. And so then you start drawing that as a fragment. If it goes to a file, then so it goes. If it goes to someone else, then yeah. So there is a correspondence, and it's not a challenging one to understand, right? And so yet another example of a fragment, right? Just all the things that come in and out of a process. Yet another. Trying to think of anything that this eliminates, just the detail that it carries on, and going from one use case to another, making a next process out of each one. All right. Good. And right, some changes. You kind of change the names. Maybe you need some data flows. Maybe you need to say some things. Yeah, laying it out on the page. You kind of go from top left to bottom right. Try not to have too many lines crossing, but sometimes that can't be helped. Tend to put data stores toward the bottom. Following example is the easiest that I can recommend. Yeah, there's nothing formal to them. The important thing is the processes, the connections, the data flows, and you're probably just going to put one together, throw it up, and it's kind of where we are, just learning it. But really, it's working it, walking through it and seeing, well, okay, I didn't really connect the right input to the output and those kinds of things that make a good use case. Send it back and redo. I wish we had a little chance to do more of that kind of iteration. And so now they're bringing in the fragments and hooking them up together. All right. And yeah. Each one of the major use cases is turned to its own DFD, and that's what happens at level 1. And those are the main processes. You can read this. The external entities you need, data stores you need. Just you bring them in. So if something that's you got to do, some of this is there's no ideal level of decomposition. You kind of a decision that, gee, this is easy enough to accomplish maybe with half a page of instructions or something like that. And breaking things up, you get more than 7 to 9 processes, then you probably should group those into some sub-processes. Okay? I always said no more than 1 page. I gave it a half page. But the idea is you'd like every circle at the bottom of the documentation level to be able to done fairly easy. That is, if you're going to stop at 3.1, the check for pending orders ought to be a page of just instructions or less. Log into the computer, open up this document, put in the salesperson, and we're checking for pending orders, okay, or pending offers, or maybe put in the vehicle ID and describe how to do that. If it takes more than a page, then you need to break that into sub-processes. That's the idea. Okay, and on it goes, just kind of walking through. Now they're breaking down 4 into its level 1 diagram. And so you kind of think about every use case gets something like this in terms, and they decided that 4.3 needed to be broken into more detail. And so there's how they decided to do that. And 5 got broken into detail here. That's level 1 diagram. And good. So memorize this too. These are the kinds of things I can check. I can't really check that, okay, you should have done 3 processes and you only had 2. That might be fine, but process verb-oriented, has an input, has an output, 3 to 7 processes, has a number on that. You can check the checklist. All right. This is something that these things you can just check and yourself. That's not a hard thing to do. It's something you have to go through. This is a little harder here, right? Yeah, did we get the content right? And that just takes work. It's the first time around. I really can't grade that too much. that occurs. So you think of syntax errors as problems that you made up here, right? And semantic errors as misunderstanding, right? You might have had a perfectly good diagram that says the data entry clerk prints their own check when they're done, but that may not be the process, okay, that they really need to have followed. That's a semantic error. That's an error meeting, right? And syntax things are easy to find. Semantics are harder because they're really representing the business. And here's your checklist of things not to do to keep my red pen. Let's see. You don't have a data flow that goes from an entity to an entity. You got to consume it in the process. If these two external things are communicating, that's outside our system. We're only interested in documenting what we get into. No name. No. The output has the same name as an input. Right. So Z, if it got processed, somehow it turned out here. If you wanted Z to go to entity B, then have a Z go to entity B, right? Data store, yeah, data stores always have an input-output chain. Sometimes you can use a two-headed arrow for that. Eats but doesn't produce anything. That's called a black hole, okay? Sometimes a miracle process or a white hole has no inputs. That's bad. That should definitely be avoided, right? Is that a data store, an external entity, something like that? I'd take this thing, it's true for process to process, into and out of a data store. I've seen two-headed, or you can have them parallel back and forth. Yeah, this is a kind of a black hole data store. That's a problem. And no process. We have entities don't shove things into our data stores. They put things into our processes that might put them in the data store. So check those things when you do. Those are the syntax errors. And if you have walkthrough, consistent decomposition, breaking into pieces, and try to use the same terminology, same names. Don't call it a budget document and then a budget transmission and then a budget proposal in different places. That's kind of naming things the same is important. All right. So I don't want to trivialize it, just like some of the other things we want to do, but it's something that just takes practice and following the guidelines, but it is just a form of communication that you need to learn if you're going to be in this business. All right, so good luck completing them. I look forward to seeing them, and until next week, I will be in touch.